Enhancing ultrasound Intima-Media complex segmentation, leveraging 4 deep learning models and self-oriented integration. Carotid artery is the main artery transporting blood to the brain. Plaque buildup in the carotid artery Intima-Media is an indicator of atherosclerosis and the risk of occurrence of stroke. As you can see in the figure, a healthy artery and an unhealthy artery where a rupture happens due to plaque buildup. Carotid artery Intima-Media thickness typically is evaluated using ultrasound images. The utilization of advanced deep learning techniques for analytics, segmentation, and the CIMT measurement in these images remain relatively unexplored. This research aims to assess the effectiveness of 4 recent deep learning models, which includes the convolution neural network, a deep self-organizing operational neural network, a transformer-based model, and a pixel difference convolution-based network. In this study, we employed 3 contemporary deep learning networks: DeepCrack, PDNet, and CC-Trans. These networks have previously demonstrated their efficacy in various applications such as edge detection, crack segmentation, and crowd counting. The DeepCrack network was originally a convolution neural network. However, we customized it by incorporating recently proposed self-operational neural network as seen in the figure. Our objective was to determine whether the CNN or the self-oriented based network would yield better results. CC-Trans was reconfigured to adopt it for ultrasound Intima-Media complex segmentation as well as PDNet. The experimental setup of the 4 networks are as follows. We can see that the training parameters of transformer-based network are higher compared to the others, whereas PDNet has the least training parameters. The experiments were conducted on a dataset which consists of 2,176 images acquired from 1,088 participants. They were multi-resolution, multi-center images. Post-processing was applied on the images to reduce the noise generated during segmentation. After experiments, the results are as follows on all the 4 models, with and without post-processing. Can be clearly seen that the transformer-based model after post-processing produced high results in terms of precision, recall, and dice. It also took less time for inference compared to others. The second best was PDNet, which also performed better in record metric. Further, the self-oriented based network performed better than the CNN-based DeepCrack network. Here's a qualitative analysis of the images generated. You can see the ground truth mask and the corresponding predicted mask for each model. In conclusion, we designed several innovative deep learning models for segmenting the Intima-Media complex IMC in B-mode ultrasound images of the carotid artery. In contrast to traditional CNN-based models, the self-oriented-based models consistently excels across all evaluation criteria. Both the pixel difference and transformer models outperforms the conventional models in all the metrics. This research presents an evaluation of 4 state-of-the-art deep learning models for segmentation. 4 models were modified for segmentation. This poster is an illustration of a published paper. The research aims to identify efficient deep learning models for accurate segmentation of carotid artery Intima-Media complex. The application's significance lies in its potential to identify the thickness of the Intima-Media, which serves as a key biomarker which plays a crucial role in the assessment of plaque buildup on the carotid artery. By accurately measuring the thickness, the application can contribute to the early detection of carotid artery plaque, which is a significant risk factor for vascular diseases. The ability to identify plaque buildup on carotid artery can be valuable for assessing the likelihood of a transient ischemic attack. Thus, this application also has potential to improve the early diagnosis and prevention of the stroke, which ultimately enhances patient outcomes and reduces the risk of stroke-related disabilities. The beneficiaries of this research are primarily medical researchers in the field of medical image segmentation. Also, with the automated segmentation, we can develop diagnostic applications such as point-of-care devices. Medical professionals and radiologists can do their work easily using automated segmentation. Further, we can develop personalized and theranostic applications for better patient outcomes. Our solution is better because automated segmentation can aid in reducing human error. Automated segmentation can handle large data sets. It provides consistency in medical diagnosis. It can also be used to develop at-home diagnostic tools, which can reduce the cost of visiting hospitals and save waiting time. Here are the references. This research was made possible by research grant support from Katha University Research Fund.